It's Mr. T here. In this video, I'm going to go over the reactions of alkenes and a couple of reactions of alkanes that we should know before starting looking at the reactions in level 3 organic chemistry. So once again, once you have gone through this video, you should feel a lot more comfortable about the reactions that you might already be familiar with. Okay, so here we go. If you just take the time now and click on this card and just see if you can answer the question here, what do you think your understanding of alkene reactions is like at the moment? Is it anything like the understanding of chemistry of the two guys on the left? Okay, reactions of alkanes. We'll just quickly go over, there's just two that might be useful when we do this level 3 course on organic chemistry. That is the cracking reaction when an alkane is heated and it's broken up into alkenes and small alkanes, and a substitution reaction where a dihalogen is added to an alkyl or alkane chain and produces a haloalkane. So we'll just look at those two. So if you want to crack some hydrocarbon, saturated hydrocarbon or an alkane, what you need to do is you take a sample of it and you put it a catalyst in there, and silicon dioxide is a good catalyst. So we use we can put in a boiling tube some paraffin, which is an alkane chain of about 20 carbons, and we can put some glass wool in there. That's insulation glass wool you might have used in your ceiling, and you heat it and it will produce bubbles of alkene, in this case specifically ethane gas. So that will produce bubbles when we heat it, and we can collect those and then we can carry out a test to see whether it's an alkene. Now what actually happens here is the alkane has been cut, or it's fractured, and when it fractures you get a small alkene made, and you get an alkane that was smaller than the original chain. So you can use this for two reasons. One is to produce lots of small alkenes, and the other one is to, if you've got a mixture like a crude oil mixture with lots of long hydrocarbons and you don't have a use for them, you can heat them in this, you can heat them with silicon dioxide as a catalyst and produce smaller chain alkanes that you might use for fuel like petrol or diesel. So the second type of reaction that commonly is used when we do assessments is the bromine water test. In the bromine water test, we take a sample of whatever we have. In this case it might be an alkane. We add the bromine water, we shake. It does nothing. We put it in UV light, and after 30 minutes it goes colorless. Now this is not an actual test for alkanes, because here's what actually happens. The bromine, one bromine atom from this bromine molecule dissolved in water, catalyzed by the UV light or sunlight with UV in it, will replace a hydrogen on an alkyl chain. So it will produce a hydrogen on an alkane. But actually, if I had an alcohol that was, say, 3 or 4 carbons long, it might replace the hydrogen on the end of an alcohol as well. The other thing it could possibly do is it could replace 2 hydrogens on an alkane chain. So it's very inspecific. It just replaces a hydrogen that's attached to a carbon. And so it will actually work with most organic products. It will, to a degree, do this reaction as well. So this is a good example, though, when we do it with alkanes, of a substitution reaction. So what we're really interested in this video is the reactions of alkenes. So alkenes there's 5 sort of specific reactions we want to know for level 3 chemistry. Those reactions are the ones we learned last year: the addition of hydrogen using a platinum or a nickel catalyst to produce an alkane, the addition of water in the presence of concentrated sulfuric acid. This year we'll most probably just have, you can write it H2O/H+, so water and the concentrate and the presence of acid will produce an alcohol. We can either add some halogens in the form of HX or and produce a or in the form of X2, like so we could have HCl or Cl2 to produce a haloalkane, or we could put them in heat and pressure, under heat and pressure, and produce a polymer. So those are 4 different types of addition reactions. And remember, the addition reactions did have their specific names. And we also have an oxidation reaction we can do. We add permanganate to that and we can produce a diol. Remember, that's the permanganate is a purple color and it goes brown when we do this reaction. So it's another test we can use for unsaturated, for double bonds or triple bonds being present for the test for unsaturation. So that's a general map of the types of reactions we need to know. Let's just go look at them in more detail. So hydrogenation is the first one. So this is an addition of hydrogens. So remember that we showed in the last screen that we had is that we could use platinum as a catalyst, PT. Sometimes you might come across that they use nickel as well as a catalyst, Ni. And all that we're doing, remember, is we're breaking this bond here and we're attaching a hydrogen to each side of that carbon. So whatever this substituent or the new thing that we're adding, it attaches one to this carbon and one to this carbon. And so we go from an alkene to an alkane. We can do hydration, which is another addition reaction. Again, we are going to attach it there. So we've got water in the presence of acid, and what actually happens is the OH from one side of the water attaches to one carbon and a hydrogen to the other. Now this is the major product here and it's following Markovnikov's rule. We'll look at Markovnikov's rule again in the next couple of slides. So what we're doing here is we're turning an alkene using our water in an acid solution, and we're going to turn it into an alcohol. Now alkenes are, I guess they're distinguishing reactions, or the reactions that are most important for alkenes are addition reactions. And it's because they have that double bond and one of the bonds breaks and it's got 2 places to add new things. So this is 2 of the addition reactions. Another one here is when we add bromine water. So this is an example of the test you might carry out to see whether you have an alkene or possibly an alkyne. You add bromine water to a sample, you shake, and it goes colorless. And what actually happens to this is a halogenation reaction. So remember, what we've got is we've got an alkene. We break the bond here, and here is where we form the new bonds, and we add these new substituents, the bromine ones. Now, you don't have to use bromine, a Br2, you could use HBr, and in that case you would add an H and a Br, or instead of bromine you could use chlorine, fluorine, iodine. Okay, so this is going from an alkene to a haloalkane, halogenation. Or we could undergo polymerization, addition polymerization, where we take just one type of molecule, and this is an alkene here. In this case it's 1-chloroethene, and we put them under heat and pressure, many thousands of them, okay, or many millions, and what they will do is they will join up in chains. They will break again at this red and this blue carbon, and then they will join to the next chain. The blue carbon will join to the next red one, and we'll get this chain along here. Remember, in order to join, it had to break one of these double bonds. So when we draw it as a polymer, we draw it as single bonds, and we draw each 3 repeating units if we're going to demonstrate that we know the polymer it goes to. So this is an alkene under heat and pressure goes to a polymer. So these are the 4 types of addition reactions we've just looked at. The addition of hydrogen using a catalyst of platinum or nickel, the addition of water in the presence of acid, and that adds a hydroxyl group and a hydrogen, or the addition of a halogen. Remember, we can add the halogen in the form of X2 or in the form of HX. The last one here is the addition, polymer addition, where we take a monomer or many monomers and we put them under heat and pressure and they will join together. Okay, there's one other type of reaction that alkenes undergo. We'll look at that after that. We've looked at Markovnikov's rule here. So Markovnikov's rule is we want to know when we get an asymmetric alkene or an alkene that isn't symmetrical, and usually it's when the double bond is coming off between the first and the second carbon. So this is, it doesn't always have to be that, but commonly it is. So this is an asymmetric one. So when we add the H and the OH from water here, there are two possible choices. Now, Markovnikov's rule says that the carbon with the most hydrogens attached in the first place is the one where the next hydrogen attaches. Hence, his rule is the rich get richer. The OH is attached to the other carbon. Now that happens for the majority of the time these molecules react. Remember, in a solution there might be billions of these molecules, or in a sample. And what you're doing is most of the reactions that happen will have the hydrogen added to the rich side and the OH added to the poor side. However, a proportion of them will go the opposite way around. So we say the majority of them, or the major product, is the one that follows Markovnikov's rule, the rich get richer, and the minority of them is the one that don't follow the rule, or the opposite of the rule. So that's Markovnikov's rule. We have to be cognizant or aware of that at all times, because when they ask us to draw the products of a reaction, sometimes they might we might have to ensure that we draw all the possible products, which could mean we have to draw a major and a minor product depending what the question is. Okay, so this is the last type of reaction that we need to know about alkenes undergoing at this level. We take a sample, we add the oxidizing agent permanganate, it's purple, we shake and it goes brown. Now it does this because the permanganate is an oxidizing agent and it oxidizes the alcohol to a diol. So the alkene to a diol. This alkene group is oxidized by the permanganate to become a diol. It gets two OH or hydroxyl groups added. Right, so if we were to summarize these again, we've got these 5 reactions. I've put some arrows and some reagents added for each one of these reactions. The thing that I would like you to do now is to stop the video and see if you can draw out this reaction scheme. Once you've drawn out what's there, go through and see if you can write what are the products formed by each one of these reactions, the reagents, and can you also write down the type of reaction that each one of these reactions is undergoing. So stop the video and then restart it again to check what the answers are. So we add platinum and hydrogen with a platinum catalyst, we get pentane. It's an addition reaction. When we add the permanganate, obviously we get that diol, pentane 2,3-diol oxidation reaction. When we add the H2O in the presence of acid, we get this pentane 2-ol, and we possibly could get pentane 3-ol. They could go to either way, and Markovnikov's rule doesn't tell us which one is favored. So that's 2 possibilities. That's an addition reaction. This HCl could also give us 2 possibilities. I've only drawn 1. And then that's another addition reaction. And the last one is also addition polymerization reaction. It produces that polymer, which is, we would have to call polypentene. It's must have got a number attached to it as well. Anyway, so those are the answers. So I hope everything went well. You got the right answers to those and you feel like you have a better understanding of the types of reactions alkenes undergo after this video. If you do, don't forget to subscribe so you can get a reminder when the next video comes up. It's going to be on alcohols. Share the video with anyone else you think might need it, and give it a like.